Here is a clean proof that E is irrational. Start with the factorial series for E. It's the sum from n equals 0 to infinity of 1 over n factorial. Assume for contradiction that E is rational. Then, E equals P over Q, where P and Q are positive integers. Multiply the series by Q factorial, and split it after the term n equals Q. Call the finite sum T. It's an integer, because for every n from 0 to Q, n factorial divides Q factorial. So each quotient Q factorial over n factorial is an integer. Also, Q factorial times E, which simplifies to P times Q minus 1 factorial, is an integer. Therefore, the remainder R, which is the difference of the two integers above, must also be an integer. Now look only at that positive remainder. It is the infinite tail beginning at n equals Q plus 1. Rewrite the tail. The kth denominator is the product of Q plus 1 times Q plus 2, and so on, up to Q plus K. Each factor is at least Q plus 1. So R is smaller than the geometric series with terms 1 over Q plus 1 to the power K. That geometric series sums to 1 over Q. Hence R is strictly less than 1 over Q, which is at most 1. Since every term of R is positive, we have 0 less than R less than 1. But a moment ago we proved that R is an integer. There is no integer strictly between 0 and 1. Contradiction. Therefore, our assumption was false. E is irrational.